On July 30th, 2025, an 8.8 magnitude earthquake struck off the coast of Kamchatka in far eastern Russia. It was one of the strongest earthquakes ever recorded by modern instruments and triggered tsunami warnings across the Pacific, from Japan to Hawaii and the west coast of the Americas. In the following weeks, several international scientific teams traveled to the area to study the changes the earthquake had caused to the seabed. What they found had nothing to do with the earthquake. Nearly 10,000 meters deep, in one of the most hostile trenches on the planet, there was life. Not a single organism, not a small colony near a volcanic fissure, but a continuous band of worms and mollusks stretching for 2,500 kilometers, a distance similar to that between Mexico City and Bogota, at depths of between 5,800 and 9,533 meters. The largest and deepest chemosynthesis-based ecosystem ever documented by science. And according to the researchers themselves, it has been there far longer than anyone can yet calculate. What we're going to tell you today isn't just the story of that discovery. It's the story of why, for more than a century, science was certain that something like this was impossible, and of a word that has appeared in religious texts for more than 3,000 years to describe exactly this type of place: the abyss. If the mysteries that almost no one dares to talk about pique your curiosity, stay until the end, because what you're about to hear doesn't end where you think. To understand why this finding made so many scientists uncomfortable, we must first understand the rules that, until 2025, almost no one seriously questioned. The Hadal Zone, the technical name for the ocean depths below 6,000 meters, covers less than 2% of the planet's surface, but it contains some of the most extreme conditions that exist outside a laboratory. At 9,533 meters, the pressure exceeds 1,000 atmospheres, the equivalent of the weight of 50 commercial airliners concentrated on every square meter of your body. The temperature remains barely a couple of degrees above freezing, and not a single photon of sunlight reaches it, ever. For decades, marine biology operated under a fairly simple assumption. The deeper you go, the less food reaches you from the surface, so the less life you can sustain. The few known exceptions, communities of worms and clams living near hydrothermal vents, those volcanic vents where boiling water erupts from the seabed, were considered tiny, isolated islands, exceptional spots in a desert, not the rule. What was found near Kamchatka broke that rule in a way no model had anticipated. It wasn't an island. It was a continuous band of life, tube-dwelling worms and bivalve mollusks in reef-like densities, stretching 2,500 kilometers across two distinct ocean trenches, without a single volcanic vent to explain such an extent. To put that figure into perspective, it's a distance greater than that between Madrid and Moscow, or between Buenos Aires and Santiago, Chile, crossing the Andes. And to understand why no one had seen it before, it's worth looking first at what kind of place this really is, and why, for almost all of human history, we didn't even know it existed. In 1872, the British Royal Navy sent a ship called HMS Challenger to circumnavigate the globe. Its official mission had nothing to do with finding the deepest point on the planet. The British were mapping the ocean floor for something far more practical, laying the first underwater telegraph cables that would connect continents. On March 23, 1875, somewhere in the Pacific Southwest of the Mariana Islands, the crew dropped a rope with a weight at the end, a routine practice called sounding. They expected to reach the bottom after a few thousand meters, as in previous soundings. The rope kept going down and down. They had to add more rope and then more. When finally something solid stopped the weight, they had descended more than 8,000 meters. Without seeking it, without yet understanding what it meant, those British sailors had just located the deepest known point in the Earth's crust. That survey was just one point within a much longer expedition. Between 1872 and 1876, the HMS Challenger traveled nearly 127,000 kilometers, collected thousands of samples of water, sediment, and marine life, and ultimately laid the foundations for what is now known as modern oceanography. No one on board could have imagined that, almost a century and a half later, that same spot on the map would still be one of the least visited places on Earth. It would be 85 years before a human being reached that depth again. In January 1960, Swiss engineer Jacques Picard and U.S. Navy Lieutenant Don Walsh descended in a submersible called Trieste to the bottom of the Challenger Deep, the deepest point in the Mariana Trench. They spent 20 minutes down there. Then they ascended, and for the next 52 years, no one returned. In 2012, film director James Cameron made the dive solo in a submersible he financed himself. In 2019, businessman Victor Vescovo made several more dives, and on one of them, right outside his window, he saw a plastic bag floating by in the most isolated place on the planet. If you've seen other videos about the Mariana Trench, you've probably already heard these names. What almost no one mentions is what they have in common. None of them were looking for what they found. The Challenger was searching for telegraph cable routes. Picard and Walsh were testing military technology. Vescovo was chasing a depth record. And yet, each of them ended up stumbling upon something that changed, even if only slightly, humanity's understanding of the ocean floor. Keep that detail in mind. We'll come back to it. Before Kamchatka, there was already a sign that something was amiss, and it happened again in the Mariana Trench. In 2024, a team from the Mariana Trench Environment and Ecology Research Project at Shanghai Jiaotong University conducted 23 dives with the manned submersible Fendus, whose name means fighter, to collect more than 1,600 sediment samples from different areas of the trench. The genetic analysis of these samples, published in March 2025 in the journal Cell, identified more than 7,000 species of microorganisms. Nearly 89% of them were unlike anything previously recorded in any scientific database worldwide. That alone was enough to worry several marine biologists. But there was a more specific detail, almost hidden among the data, that caught the team's attention. In the deepest zones, the microbes didn't live as isolated organisms competing for scarce resources, as theory predicted. They formed cooperative communities, grouped in biofilms, where different species exchanged nutrients with each other. For the study's authors, this was behavior typical of a rich ecosystem, not of what was assumed to be one of the most resource-poor environments on the planet. For months, that was the news. A trench, thousands of unknown microbes, cooperative behavior never before documented at that depth. Enough for several headlines, several videos, several articles. What almost no one anticipated was that this same trench, the Mariana Trench, would end up being just the first chapter. Because thousands of kilometers away, on the other side of the Pacific, something much bigger was about to come to light, for a reason that had nothing to do with biology. On July 30th, 2025, at 11:24 a.m. local time, the Earth's crust ruptured off the Kamchatka Peninsula. A fault segment hundreds of kilometers long suddenly shifted, releasing energy that, according to seismological estimates, was equivalent to hundreds of nuclear bombs. It was classified as one of the 6 strongest earthquakes ever measured with modern instruments. The resulting tsunami reached the coasts of Japan, Hawaii, California, and as far south as South America, forcing precautionary evacuations in several countries. The world's attention, understandably, focused on the damage, evacuations, and the risk of aftershocks. But for a group of oceanographers, an international team of researchers from China, New Zealand, Russia, and Denmark, that earthquake transformed one of the deepest and least studied regions on the planet into an urgent priority. The Kuril-Kamchatka Trench and the Western Aleutian Trench are part of the so-called Pacific Ring of Fire, the chain of trenches and volcanoes that almost completely encircles the ocean and is home to most of the strongest earthquakes ever recorded. These 2 trenches went almost overnight from being a blind spot on maps to the exact place to look. The team redeployed the Fendus submersible, the same one that had collected samples from the Mariana Trench a year earlier, for a new series of dives. The stated objective was to study the geology of the area after the earthquake. What they found along the way wasn't on anyone's to-do list. The expedition made 23 additional dives in the Kuril-Kamchatka Trench and the Western Aleutian Trench, reaching depths of between 5,800 and 9,533 meters. To put that in perspective, 9,533 meters is deeper than the height of Mount Everest, and it would still be more than 1,000 meters short of reaching the bottom of the Mariana Trench. On 19 of those dives, the Fendus cameras recorded something that, according to the report published in the journal Nature, no member of the team expected to find at that depth. Dense clusters of tube-dwelling worms, of the type known as suboglonid polychaetes, alongside large clams, forming colonies comparable in density to a shallow water reef. Not in a single spot, but along 2,500 kilometers of the trench. The study's lead researcher, Mengrandu, from the Institute of Deep-Sea Science and Engineering at the Chinese Academy of Sciences, explained that the most surprising aspect was not just the depth, but the abundance and diversity of life sustained by chemosynthesis, the process by which certain organisms obtain energy from chemical reactions rather than sunlight, on a scale never before documented. The team, comprised of researchers from China, New Zealand, Russia, and Denmark, published their results in Nature, one of the world's most rigorous scientific journals, adding an extra layer of scrutiny to a finding that would otherwise sound almost unbelievable. To confirm this, the team used isotopic analysis of the collected samples. The results showed that the worms and mollusks obtained their energy from methane and hydrogen sulfide seeping through deep faults in the sediment, gases produced over millions of years by the microbial decomposition of organic matter buried beneath layers of seafloor. Given the geological similarities to other hadal trenches around the world, the team suggested that this type of ecosystem might not be unique to the Kuril-Kamchatka region, but rather far more common than anyone had imagined. It's just that, until now, no one had looked in the right place at the right time. Let's focus on the numbers because they deserve to be alone. 2,500 kilometers of seabed teeming with life. Depths of up to 9,533 meters. The largest and deepest chemosynthesis-based ecosystem ever documented in the history of science. And nobody knew. Not because it was hard to imagine, but because no one had ever had a reason to go looking for it there, at that exact moment. Mengrandu's team wasn't out hunting for a new ecosystem. They were there to assess the effects of an earthquake. Remember the detail we mentioned earlier? The HMS Challenger in 1875 wasn't looking for the deepest point on the planet either, but rather routes for telegraph cables. Picard and Walsh were testing military technology. Vescovo was chasing a record. And now, 150 years after that accidental sounding, a team that arrived to study seismic damage ended up documenting the most extensive community of life ever seen in the hadal zone of the planet. The pattern is hard to ignore. Every time humanity has learned something truly new about the ocean floor, it's been because we were looking the other way. And this is not even the most debated discovery in recent years in this same region of the Pacific. More than 4,000 kilometers away, in an area of the Pacific called the Clarion-Clipperton Basin, between Mexico and Hawaii, the seabed is covered with potato-sized rock formations rich in manganese, nickel, cobalt, and copper. They are called polymetallic nodules, and several mining companies, with permits from the International Seabed Authority, plan to extract them on an industrial scale in the coming years. In July 2024, a team led by researcher Andrew Sweetman published a finding in Nature Geoscience that, as he himself admitted to the scientific press, surprised even him. Their measurements showed that these nodules generate voltages of up to 0.95 volts on their surface, almost enough, when combined among several nodules, to reach the threshold necessary to split seawater into hydrogen and oxygen through a process called electrolysis. Without sunlight, without photosynthesis, in total darkness, kilometers deep. They called it dark oxygen. The implication, if confirmed, is significant. For nearly 2 centuries, science has taught us that all life on Earth ultimately depends on photosynthesis as its primary source of oxygen. If rocks on the ocean floor can produce oxygen in total darkness, it would mean that a second, independent source has been operating down there for millions of years, and that similar conditions could exist in the subsurface oceans of icy moons like Europa or Enceladus. The discovery did not go unanswered. A team led by researcher Chao-Min Sun of the Chinese Academy of Sciences presented a study, still under review, that proposes a different explanation. 2 types of bacteria, not the nodules themselves, are responsible for producing this oxygen without light. Other teams directly requested the retraction of the original study, arguing that the methodology might be flawed. As of early 2026, no other laboratory had independently reproduced Sweetman's results. The debate continues, and while scientists argue, the very companies hoping to extract these nodules, which could be producing oxygen, continue to move forward with their plans. What the Kuril-Kamchatka discovery and the dark oxygen debate have in common is not biology. It's what they reveal about the gap between what we think we know and what we've actually seen. There is a Hebrew word, tiham, that appears in the first chapter of Genesis. Almost all translations render it as a single word in English: abyss. And darkness was over the face of the deep. The text says, before anything else exists. The complete phrase describes the earth at that moment with two other Hebrew words, tohu v'ebohu, which are usually translated as formless and empty. It is almost literally the description of a blank map. The same word, tiham, reappears in the flood narrative in Genesis 7 verse 11, when all the fountains of the great deep burst forth and water covered the earth. In the book of Job, the abyss is the dwelling place of Leviathan, a creature described as untamable, hidden beneath the waters, beyond the reach of any human being. For thousands of years, long before oceanography existed, various religious traditions had already identified something about the depths of the sea. That there was something down there. Something vast, something hidden, something that humankind was not meant to see, and which, according to those same texts, is only revealed when it is broken. We're not saying that Genesis accurately described a 2,500-kilometer-long chemosynthetic ecosystem. What we can say with the data we have today is this: for decades we've been making scientific, economic, and regulatory decisions about the ocean floor assuming we know its general shape, even though we've directly observed less than 1% of its surface. The companies planning to mine polymetallic nodules in Clarion-Clipperton operate under that same assumption, that they know enough about what's down there to start disturbing it. What the Kamchatka earthquake showed, unintentionally, is that this assumption can be wrong in ways we didn't even know how to frame as a question. And it leaves an uncomfortable question open. If a 2,500-kilometer wide band of life could go unnoticed until an earthquake forced someone to look precisely there, what other sources of the abyss, biological, chemical, geological, remain exactly where they always were, waiting for the right accident to come to light? To conclude, it's worth returning to something we mentioned at the beginning. Every major discovery about the ocean floor, from 1875 to 2025, came about because someone was looking for something else. Never because someone decided one day to go and check if there was something down there that we didn't know about. This raises a question that isn't just about the ocean. If most of what we know about the deepest place on our own planet came about by accident, how many other things, about history, about nature, about what we were taught as children as absolute truths, will remain uncharted until something by chance breaks through them? If this question got you thinking, it's no coincidence. It's exactly the kind of story we tell on this channel. Verifiable discoveries with named sources that almost no one else is reporting in Spanish with this level of detail. If you want to keep exploring the places and the questions that most prefer to avoid, subscribe and turn on notifications, because the next grave we're going to open isn't in the ocean. It's in a document that was kept hidden for over 60 years and, according to those who saw it, should never have been made public.